is no biased. Okay, and in no bias we have seen current equals to 0. Forward biased current will get, and reverse bias will get leakage current. Yes or no?
Yes, sir.
Yes, sir.
We have seen all the operation, how this minority majority carrier moving, and depletion region, and how the depletion region is decreases in forward bias, how it is increases in reverse bias, and built-in potential. All those things we have discussed. Now, the current and voltage relationship can be represented by a graph which is called as IV characteristics or VI characteristics. For that, what I'll do, I'll take two axes. X-axis will take voltage because this is independent quantity, unit is volt, and y-axis current, unit is milliampere. Okay, always whenever you plot, take dependent quantity in y-axis so that the graph will be correct. When we apply voltage, then only current will flow. So if you plot no bias condition, V equals to 0, what is my current? 0. So 0 means origin. This is your 0 value. Now when I increase the voltage in positive direction, initially very less current will flow. The part up to which depletion region exists across the junction, and when you increase the voltage, then slowly the depletion region will reduce, and after some time at certain voltage the depletion region will vanish. So up to depletion region exists, the current is very small. Once it overcomes this depletion region, then current will increase exponentially. So the point at which, or the voltage at which depletion region reduced to 0 and current increases is called as threshold voltage or knee voltage or cut-in voltage. That can be represented as Vt. Sometimes it is also written as Vf. So you can consider that as Vt or threshold voltage. So this is 0.7 volt for silicon and 0.3 volt for germanium diode. Up to this clear?
Yes, sir.
Now when you consider the reverse voltage, that means V less than 0, will get Is. So Is can be plotted like this. So this is your Is or leakage current. Okay, and generally it is in micro, nano or picoampere. But if you increase the voltage further, right, minus V further, then after certain voltage, suddenly the current will increase. Suddenly the current will increase. So this point, current will increase, and the huge amount of current which is increases can also break the diode. Means the diode can burn. So this is called as breakdown voltage. Okay, VPR, and this region I can take as PQ. So this PQ region is called as breakdown region. Okay, And before this breakdown, suppose I have observed that at minus 5 volt, huge amount of current is flowing. At minus 5 volt, huge amount of current is flowing and diode may burn. So just before this 5 volt, maybe minus 4.9 volt, we can take the maximum voltage which we can apply. Okay, so that is represented as PIV. PIV. So what is the full form of PIV? Peak inverse voltage. P inverse voltage. Okay, so you know peak means maximum, inverse means negative voltage. So the maximum reverse voltage that can be applied to the PN junction without damage the diode is called peak inverse voltage. Is it understood?
Yes, sir.
So whatever we have discussed, that is written here. The plot between current and voltage is VI or IV characteristic in forward bias condition. VF less than VT. VF means instead of V, here it is written VF in this diagram. So when VF means what? Instantaneous voltage. When this instantaneous voltage is greater than VT, less than VT and very small, then a very small current will flow. And when it is increases from this VT, that means overcome this depletion region, then current is increases exponentially. So generally it is 0.7 for germanium and silicon 0.3 volt, and in reverse bias after a point shown in the figure P, reverse current increases suddenly and almost parallel to y-axis, and the current may damage the diode. So that is called as breakdown voltage. Clear about this characteristic? So this is your forward bias characteristic. This is your reverse bias characteristics. Forward bias characteristic in first quadrant and reverse bias characteristic in the third quadrant. Any doubt you can ask. Now, in this diagram, we observe the equation how the current is increases in the forward bias condition. So in forward bias condition, I can write the diode current as ID. That means after threshold voltage. Okay, so this region is ID. Okay, once it increases or depletion region removes, current increases. That current we can describe as a diode current and is given by IS, that is leakage current, e to the power V by Vt minus 1. Okay, so let this Vt will be capital because already you have taken small Vt. So what are these terms? ID, diode current, C is leakage current, this is also called as reverse saturation current. V, applied voltage across the junction. Here it is written Vd, so you can also take Vd. And Vt, do you remember what is Vt? It is a constant and the value I have told you. dP by
26 millivolt.
26 millivolt. It is thermal voltage. Okay, so this is the equation. So current and voltage relationship of PN junction diode is this one, and that can be simplified for reverse bias and forward bias also. Mostly, if you consider this is instead of this forward bias criteria, I can write diode current equation. Diode current equation. So we see this is exponential function. So current is actually increasing exponentially. In the reverse case, it is minus Is. So mathematically, we will see how it can be derived, so that we will get a logical conclusion that theoretical thing and mathematical thing match each other, and you will verify. You have already verified, I think, in the lab also. So if I take V equals to 0, that means this condition, what will get? I equals to, or ID equals to Is e to the power Vd by Vt minus 1. Now Vd is 0, means what? E to the power 0. So Is 1 minus 1, that is 0. Yes or no? This is your 0. At this point, voltage is 0, so current is also 0. Now when V greater than 0, okay, much greater than, you can take. So ID equals to Is e to the power Vd by Vt minus 1, and if Vd is much greater than 0, then what happens? E to the power Vd by Vt much greater than 1. This exponential value will be much higher than 1. Do you agree or not? Are you getting or not? When voltage increases, for high positive value of Vd, the exponential term will be more than 1.
Yes, sir.
So we can neglect this one. So ultimately, what I'll get? ID equals to Is e to the power Vd by Vt, ignoring this one. Okay. Now you see here, this is an exponential function with Is. So that's why after this point, the current is increases exponentially due to this exponential function. Now when V less than 0, what happened? ID equals to Is e to the power Vd by Vt minus 1, and Vd is less than 0 means e to the power Vd by Vt, or minus this is equals to 1 by e to the power Vd by Vt. So this denominator is more, means the term is decreasing very fast, is much less than 1. Exponential negative function means what? It will decrease very fast. So as compared to 1, its value is very less. So we can neglect this exponential term compared to 1. So what we'll do, ID equals to Is. This exponential term I'll put it as 0 minus 1. So finally I'll get Is. Clear?
Yes, sir.
So this Is, this negative sign indicate reverse direction, and this is your Is. And you can see some dotted mark is given here. That means some break is there in this line. It is not continuous because I don't know at what voltage the breakdown will start. Depend upon the condition, depend upon the type of diode, depend upon the material which is used, like silicon, germanium, or any other type of semiconductor. It vary. So in general, if you consider at some point it will break. So to indicate that, this breaking or dotted things are mentioned in the graph. Clear? Any doubt? So that operation wise, last class we have seen why in forward bias current is increases, why no bias, no current, reverse bias, leakage current, and mathematical thing and graphical thing we have understood how whether it is matching or not. And in lab you have performed this one, and you are getting this thing. Have you done this one in lab or not? If this lab is completed or not?
Yes, sir.
So it's completed.
Have you got this exponential increasing function?
Yes, so
Okay. But I think forward biased you have used PN junction diode. Reverse biased you have not used PN junction diode. You have used Zener diode. Because
Yes,
if you
sir.
use PN junction diode in reverse bias condition, then it will break or the diode will burn. So that's why the Zener diodes are specially designed diodes which can operate in the reverse bias condition. Even if the current will increase, it will not break or it will not burn. So that's why in reverse characteristic testing we have used Zener diode to protect and understand the diode principle or characteristic. Now if you want to find any of the term, then you can easily find, like this is the equation. If I you need to find, then you need to know Is and V, means what is the leakage current and what is the applied voltage across the diode. If you know Id or I, total diode current, and leakage current, then you can also find what is the voltage I need to apply. So that can be a simplistic formula we can derive from here. I will take because obviously in forward bias only we have to find the current or diode current. In reverse bias we are not getting any diode current, leakage current is flowing. So that's why this is removed. Just now we have seen in the characteristic, in this condition we have taken diode or voltage applied is positive and this one is ignored. So in this condition only we need this Id. So one is removed. Just to take Is to left side and take ln both the side and separate, and to find out V, will get Vt ln I by Is. That means what it gives, how much voltage I should apply across the diode so that I can get maybe 5 milliampere of current or 7 milliampere of current if you know the leakage current. The question will be like that. Suppose a silicon diode is taken and it was observed that 2 nanoampere current is flowing as reverse leakage current or reverse saturation current. Then how much voltage we should connect so that 5 milliampere current will flow across the diode. That means indirectly Vt is given, we know 26 millivolt, Is is given as 2 nanoampere, and we need to flow 5 milliampere current as Id. You need to find out what is V. Do you understand how to solve? I'll give 3 questions here to solve. Now we'll see how the diode will act as a switch. Already we have seen the diode symbol is like this, and when the diode is connected with positive voltage greater than Vt, then current is flowing. I. And when the diode is reverse biased, that means V is negative, then current is 0. You have understood this one? In a circuit condition I have represented here. Now when current is flowing, it needs path. That means we can say the 2 points are sorted. That means we can replace this diode and can join, sorry. Okay. So these 2 points are joined so that the current will flow. So in place of diode, we can use short circuit condition. Short circuit means what? Current will flow and the potential difference between these 2 points is how much? Let us take this is 0.1, this is 0.2. What is the potential difference between these 2 points? What is the potential difference between 0.1 and 0.2? Suppose this is 0, this is V1, V2. So V1 minus V2 is equal to 0 because both are same point. There is no resistance, nothing inside or in between them. The potential difference between these 2 points is 0 or shorted. In short circuit only current will flow. So V equals to 0, but I'll get current here. Now in reverse bias condition, what happens? Current will not flowing. Current is not flowing means what? These 2 points are sorted or open? Open circuit. Okay, they are not connected. That's why current is not flowing. So this is open. So I'll have some voltage. I'll have some voltage and current is 0. So that's why this diode is replaced as open circuit. So whenever you try to solve or use the equivalent circuit, we'll discuss in later case. Simply or ideal model, we can replace the diode as short circuit for short bias and open circuit as in reverse bias condition. And that is like a switch. When you apply V greater than 0, current is flowing. That means like when we switch on the electrical switchboard, then maybe our light, fan, everything will whatever connected to that switch will be operating. That means current is flowing. When you release the switch position, then current is not flowing, the circuit is turned off. So same way, if we use the diode in forward bias condition, current is flowing. When you not use in forward bias or reverse bias condition we use, then current is not flowing. So we can say that is acting as a switch. Now we see the diode resistance. So we know resistance means what? Whenever current flows, we'll see the resistance and it will obey Ohm's law. So obviously that is linear circuit, but in case of diode, we are getting like this characteristic. And forget about this thing. You consider forward bias condition. Is this linear or non-linear? This graph, forward bias condition, it is linear or non-linear?
Non-linear.
Okay, so it will not obey Ohm's law, but still we'll get resistance because current is flowing and we are applying voltage. So resistance is defined as opposition offered by the material to flow of current. So diode resistance can be defined as the effective opposition offered by the diode to flow the current through it. So diode offers a very small resistance in forward bias condition because a lot of current or you see exponential current rise. So obviously the current, the resistance which is offering by this diode is very less. Uh, Diode offers a considerable resistance in the reverse bias condition because a lot of resistance offered, and we are getting very small current in this reverse bias condition. We are not considering this breakdown because the diode will burn. So diode resistance are classified into two types. One is static and dynamic, depend upon which current source is connected. If DC current is flowing, then it is static resistance, and AC current is flowing means it is dynamic resistance. Okay, so static resistance means, or a static resistance, or we can also say DC resistance of a PN junction diode defines as the ratio of voltage to current at any point. So if I take this is my point where I want to find out the resistance across the diode, then how much voltage I have applied and how much current I'll observe, and simply take the ratio, then I'll find the DC resistance. Suppose I want to find out the resistance at this point, then I'll take the current and voltage. What is my voltage? What is my current? And I'll take RDC1 equals to V1 by I1. Can these two resistance equal? Tell me. Where suppose I'm taking 2 point and two resistance I have calculated by this voltage and current, will they same or different? Different or same?
So different because it doesn't follow Ohm's law.
Very good. So it is non-linear. So that's why it is non-linear means it will not same. It will vary. Okay, because the proportion in which this change, it will not vary same proportion of current. Now what is dynamic resistance? Dynamic resistance is the resistance offered by the diode to the flow of AC current through it when it is connected to a AC voltage source. So here we will not take any particular point, as AC means the alternating thing. So what is the change in voltage for a particular time period, and during the change in voltage, how much change in current we will observe. So suppose I'll take this point and the voltage is varying like this. So I'll observe across this, that means this much of time, this is the time axis. So across this time, what is the variation in the current? So I'll observe the variation of voltage, that is dV, and what is the variation of current, that is ID or del Di. Then I'll take the ratio. Then I'll get AC resistance. Then I'll get the AC resistance. So change in voltage and change in current is required to find out AC resistance. And that can be also calculated graphically if you know the slope. That means if you plot a slope like this. Okay, so this is the slope. Slope means what? Dy by dx. So dy is your di, dx means dv. So this is your slope. So if you see this one and this one, it is the inverse relation or not? Yes or no? So I can write RAC is equals to 1 by slope also. That means if graphical representation is given, like here 2 volt, here 3 volt, so difference is 1 volt. Let us take here 2 milliampere and here 6 milliampere. So difference is 4 milliampere. So you can take like that to find dV by di and RAC. Or if slope is given, suppose slope is given as some value, then directly you can put slope here. So 1 by slope is equals to your AC resistance. Is it clear to all? Guys, is it clear to all or not?
Yes.
Or any doubt? So once you complete this one, to solve these three problem, and tell me what is the answer or how to solve it. Let me first solve. You first try. First question: a silicon diode is biased with 1.2 volt, so that leakage current is 40 nanoampere measured. Find the diode current across the junction. Very simple. What is the diode current equation? This is the diode equation, right? So what is given? Biased with 1.2 volt. That means what value is given? Can anybody tell? V. V is given. This is the bias voltage which is connected to the diode, and leakage current is 40 nanoampere. That means what data is given?
Yes.
IS is 40 nanoampere. VT you know, that is 26 millivolt. Now you put everything and you find ID equals to 40 into 10 to the power minus 9 e to the power 1.2 divided by 26 into 10 to the power minus 3. I am converting everything to SI unit because 1.2 volt is given, minus 1. You calculate and tell me what is the answer. Anyone who has done? You have to tell the answer. Don't sit idle. Lot of time I have observed
32 nanoampere.
32.
0.3.
0.3 nanoampere.
Yes, I guess.
No, nano means it is very small current. You check again. This answer is not correct. That's why I am telling everyone should try, because a lot of time I have observed everything is correct but final answer is wrong. So calculation, many of the students don't know how to use calculator. So that gives you negative answer and you get less mark. First you calculate 1.2 divided by 26 milliampere. This value you find, then e to the power that value minus 1, then you multiply with this.
Sir, 4.12.
4.12 what?
Sir, 4.4 into 20
Any other answer?
Sir, 33.9 into 10 to the power minus 10.
33.9 into minus
10.
9.
Sir, 10.
Sir, 5.06 into 10 to the power minus 6.
5.06 into
10 to the power minus 6.
minus 6. Any other answer? So first you tell me, you have told me the number. You have not told me the unit. Whether it is ampere, milliampere, microampere, nanoampere. You have not told me.
Sir, 4.12 nano.
Nanoampere. Second one. Because without unit, this is only number.
Ampere.
Ampere. All these are ampere.
Yes, sir, ampere.
Okay. Now 4 persons have told 4 answers. Which one is correct? Majority of students getting which result? Let me calculate. 1.2 divided by 26 into 10 to the power minus 3. That is come as 56.15. So, e to the power answer minus 1. So if you calculate this one, you will get to 1.1 into 10 to the power 20 into 40 into 10 to the power minus 9. 4.43 into 10 to the minus 12, plus 12. So this answer is somewhat correct. It will be 4.43. So you check again whether you are getting or not, where you have made mistake. One or two persons have only got this answer. Where you have done wrong, you again check it.
Sir, I also got the same answer, sir. First, I told the third answer, sir, but that exponent part I have done wrong, sir.
Yeah, this exponential part and multiplication.
Yes sir, वो कैलकुलेटर में कोई कैलकुलेटर में नहीं दिखाता, इसलिए गलत हो गया.
क्या नहीं है?
सर, समटाइम्स मोबाइल वाले कैलकुलेटर में एक्सपोनेंट वाला पावर
नहीं, मोबाइल कैलकुलेटर तुम यूज नहीं करोगे ना, तुम साइंटिफिक यू शुड
यस सर, सॉरी सर,
साइंटिफिक कैलकुलेटर. ओके.
Yes, sir, we are using mobile calculator, so that's why.
No, you should use scientific calculator, and you must know all the features, how to use the calculator. Okay, that is required. Once you see this one, next move to the second question. So solve second question and third question. What is given in the second question? Silicon diode is connected in forward bias so that 80 milliampere current flows across the junction and 60 nanoampere leakage current. That means I is given as 80 milliampere and IS is 60 nanoampere. Find the applied voltage across the junction. Just now we have seen this formula. This one. Okay. So what we will do? It is asking this V. So V equals to Vt. 26 into 10 to the power minus 3. Ln I is how much? 80 into 10 to the power minus 3, and this is 60 into 10 to the power minus 9. Tell me what is the voltage?
अरे ऑनलाइन मतलब ऑनलाइन नहीं है, वो लोग लैपटॉप लेके ही शेड्यूल नहीं समझे.
Are you getting how we are putting all these things?
वो लोग बस इनको बोलेंगे क्लास.
Yes, sir. Yes, sir.
Now answer. You have to take ln, okay, not log. If you take log, the answer will be different. Anyone got the answer?
Sir, 0.37.
0.
Yes, sir. 0.366 or 37.
366. Okay, so
Yes.
it might be a germanium diode because silicon diode threshold voltage is 0.7 volt and germanium is 0.3 volt. It is not mentioned anywhere, so we can predict this is maybe germanium diode or something, some diode which have the threshold voltage less than the 0.366 volt. Yes or no?
Yes, sir.
If that was silicon diode, it must be more than 0.7 volt. Now, last question, you can find same type of question. Ratio of forward current and reverse current is given as 10 to the power 8. Okay, so the same question in different language it is written. That means directly it is giving as this value, the ratio of diode current and leakage current, that is as 10 to the power 8. Okay, so you can calculate same way. 26 into 10 to the power minus 3 ln 10 to the power 8. Find out what is the answer.
Zero point 478.
478. 0.478.
478. So I think now how to apply this formula and how to use these things is clear to all. You can able to solve these questions if coming in the exam.
Yes, sir.
It needs little bit practice. Okay, so you can frame your question. The type of question I have given you, you can frame your question like suppose a diode is given and some voltage I'll connect with leakage current. Then what is the total current, or the ratio is given, or to find out voltage. To practice those type of question. Also, I'll provide some question to you for practice, and in assignment also I'll give one question, so you can solve it easily.
Sir,
Yes.
sir, is there in same type of question in the AEC book?
Yeah, same type of question will be there. You can search.
Okay,
Three
sir.
type of question I have given. Actually, the parameter is three. There are three parameter: ID, IS, and V. So three type of question I have given. So you can search same type of question also in book. So we'll stop it here today. Next class we'll go for application and one quiz. So quiz will be covering the basics of semiconductor and up to this diode equation. Okay, maybe 10 question, 10 minute I'll give.
Sir, MCQ type, right?
MCQ type, maybe one or two problematic, this simple problem like we have discussed today. Otherwise, fundamental questions I'll put.
Sir, in Google form or we have to write?
Google form will do.
Okay, sir.
Sir, in 10 minutes only.
10 minutes is sufficient. The questions will be
Okay, sir.
according to that only I'll put the question.
Okay, sir.
You will have to finish the syllabus also, na? April is your exam,
Yes,
so that's why.
Sir, in exam till which chapter will get?
Exam is not means overall I know, but it is not finalized up to transistor first part. Generally it will come, but I don't know because offline and online exam will be maybe simultaneously, and they have come little bit late, and almost 30-40 sections are there. Whose section is going fast, whose section is going little bit late. So overall we'll see, and according to that only the call will be taken. But mostly this diode and transistor, some portion, initial portion of transistor.
Okay, sir.
Okay, so we'll wind up for today.
Attendance, sir?
I have already taken.
Okay.
Okay, thank you.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.